So I'm now recording this, at least my feed. So this will be up, um, again, barring technical issues. Um, so you can go back and kind of pause and look at what we've done here today, which again is often helpful, especially when dealing with Excel or some in a new program. So what we're going to do in Excel, my hope is that we'll have some experience describing some variables. So we'll walk through how Excel can quickly kind of give us those descriptive statistics. So the mean, the median, the range, things like that, and then also things like standard deviation. And we're going to kind of slog our way through the by hand version of calculating those in Excel, and then also look at the ways in which Excel can do that for us. And then I also want to, we'll do a similar thing, but we'll do it with grouped data. And so I know that you all have, in the Connect assignment, there's a couple questions relating to group data. And it kind of forces you to smush two concepts together. So we'll take a look at some of that in Excel as well, and hopefully that'll clear up some of those questions that I know some of you are having as far as how do we actually crunch the grouped data questions. Okay, so yeah, again, feel free to either speak up, or again, if you throw something in the chat, I'll try to keep glancing at that as we go. So I'm going to, if I click the buttons right, my goal here is to show you the Excel file. And so hopefully that shows up now. I see it's a little fuzzy. I think Zoom is just maybe not grabbing my feed very well. But hopefully you can see it. Maybe we'll zoom in a little bit, and hopefully that'll help. At least it'll be bigger and fuzzier. But the video I post should be clearer than this. That reminds me. So technical snafu. I think I sent an email about this. I'm not sure. But I posted the a video or a lecture, but it's a re-recording of the lecture because while audio was coming through on Zoom this week, it was not feeding into kind of my video system on my computer. So it was just me miming things up at the whiteboard. So I re-recorded that so you can go back and look at the same examples we walked through in class. So if those were going quickly, or if you kind of lost track of what we were trying to accomplish, you can go back and kind of rewatch it, pause it, and work through those examples yourself. Okay, so really, again, the heart of, I thought I was still going to be on the screen. Hello. The heart of what we're trying to do in chapter 3 again, and really again 2, 3, and 4, is describing data, and that's one of the big things of statistics, right? So how do we take all of this wealth of data and summarize it and tell the story of the data? And so in chapter 3 here, we're learning some of those numerical methods, so I have in front of you, and it's or at least on the screen, or if you've opened it up in Excel, some data on home sales, and somewhere down here I have listed that it's a random sample of homes sold in one city in the last month. Okay, so it's so I've kind of highlighted there that it's a sample, right? So when we're doing some of these equations today, we're going to be working in the sample versions of them. So what I'd like to do is, so we have this data in front of us, and it's just a big wall of numbers. So how do we make sense of what's going on? And I'll tell you that some of this early on stuff can feel a little trivial. You've probably done means and medians before, but I will tell you that this is often the very first thing that a data scientist, when they grab a new set of data, they go through many of these same steps as to how to start to grasp what's in front of them. We have, in our data set here, we have, I've just listed them so we have some way to kind of count them up, but we have what price it sold for, what they listed for, the square footage, the lot size, how old the home is. This could be a little clearer because this could be, how old the buyer is, but this 144 probably tells us that it's the age of the house. And then we have, your typical statistics of how many rooms, bedrooms, and baths it has. So could be pretty useful information, if you work in the housing industry. But also, it turns out that housing prices and things like that are pretty. They're decent indicators for other larger aspects in the economy. So lots of agencies and government agencies will look at home sales price data, but also if you're ever in finance or in banking or something, these are numbers that they kind of keep aware of. So just again, so we're going to be kind of jumping around this sheet. So when we're doing that in Excel, it's often, and I know we've talked about this before, but it's always good to remind ourselves. I'm gonna freeze the panes here, and I'm gonna do it. We're gonna be focusing in a lot on the selling price, so I want to be able to make sure that I can always see the selling price and the top row. So I'm gonna do. I've clicked on C2, and so what that's gonna do is lock everything above C2 and to the. Which way is my hand go? Everything this way. Everything to the left on the screen of C2. Okay, and so you can kind of see the line, the slightly darker shaded line. But now when we scroll down, we can keep seeing what we're dealing with. Same thing if we scroll to the left. Selling price comes with us. Okay, so that'll just help us as we move around. Yeah. So when we get this new data, again, much of what we learn in chapter 3, right? We want the mean, the median, all of those types of things. And so we're gonna quickly calculate those for all of these variables. And I've gone ahead and done it in the first for the selling price. So if you want to see the specific formula, you can click in that cell, right? So I've just clicked along it, and you can go up to the formula bar and see it there. I've also listed it here. Just to remind ourselves kind of what we're looking at. So you can see that that's the mean is average. And so we can quickly have Excel calculate these rather than having to do it by hand, right? Adding them all up and dividing by n. We can do average. Okay, and then I'm going to grab the data, and that's going to quickly calculate the mean for me. So now I know the mean listing price was $346,000. And now, just from those two calculations, I can see how that might give me some good insight as to selling prices end up being pretty close to the list price. Whereas when I just look at that wall of data, it's hard to grab kind of what that is. Yeah, so I could continue to do this, right? So I can do median, grab this data. But as we get more familiar with Excel, we're going to learn some kind of tips along the way to make our lives easier. Okay, and one of those that hopefully we're picking up on is that we can drag cells in Excel. So when I drag, so I have average of C5 to C41. If I drag that value, and I wish I could point at it. I don't even know what direction to point, but if I drag this to the right, it's going to update it for me and take the average of the column above it. Okay, Excel is smart enough to realize that if I'm moving over a column, I probably want to take the average in the same from the same area. Okay, so now that's from D5 to D41. And so I can see the average square footage. And so I can actually drag that all the way over and see the averages of all of those variables. Same thing with the median. Okay, I do have a little bit of, so it's always good to kind of verify and make sure we don't want to update our cells. I think I need to format this because I don't want the acres rounded. So I'm going to format this cell and give it some decimal places. Put it back in line with my data. So you can always just select your data, right click and go to format cells, and that'll show you that option there, and you can select from a whole host of different options. Okay, and actually it same thing over here. I probably want to give a little more specific there, so I can see a little more nuanced look at that. You might even want to go with 2. Okay, so again, now we have a way to quickly, take the mean, the median of these. Same thing is true for max and min, right? So we learn about those in chapter 3 as well. Those are easy to remember. It's just max and min. Let's drag that over. Again, it's going to update. I'll reformat those. Well, actually, though, that's going to be the max because there's not going to be decimals. And I'm just going to drag over from here, and it's equals min. And there we have the max and the min. And now the range, again, so this is the first time we talk about spread, right? So how do we talk about how spread out our variables are? Range is kind of the simplest way to think about that. And that's just simply the max versus the min. Now, as far as I'm aware, actually, I don't think there is a specific range formula. I could be wrong on that, but there doesn't really need to be one because you can simply just use the max versus the min. And so you can just select the 2 values here, so the max and the min. Okay, you can combine. So in Excel, I can do equals max of this data minus the min of this data. Okay, and this will be a functional formula. Okay, so you can basically combine formulas within a formula, and that'll give you the range. Okay, so both of those are viable ways to go about it. Okay, so again, you can see how much easier this is than plugging this out on scratch paper. So now I want to take just a pause, and I want us to focus in on the mean and the median. Okay, and in chapter 3, this is our first introduction to the idea of skew. So just from the mean and the median, we should be able to guess whether the skew is going to be positive or negative. And this is, as we'll see in the next chapter, there are multiple ways to calculate skew, but they largely work in very similar ways. And as you, when we jump into chapter 4, I'm going to have you really only focus on one of the calculations of skew, just because nobody really does it by hand anyway, so we don't need to stress too much. But I do want you to kind of understand how it is calculated. So remember, skew, if we think about our data being symmetrical, skew talks about whether or not it's not symmetrical anymore. Is it pulled in one direction or the other? So if you remember from the book, you can have no skew, you can have a positive skew or a negative skew, right? And so one way to think about that is their data kind of more on the extreme end of one side? So for instance, in this positive skew, we have values that are much larger that are pulling that mean forward. And so when we have positive skew, the mean tends to be larger than the median, right? Mean and median, we think of them as both measuring kind of the center of the data, and sometimes they match up and they're kind of overlapped, but not always. So if there are large values, that mean is going to be pulled towards, I'm never going to figure this out, pulled towards the kind of higher values, whereas the median remains in that middle. So we can see skew visually from something like a histogram, but we can also kind of anticipate it by looking at the mean versus the median. So going back to our data here, we have a mean that's greater than the median, and so what that indicates to us is that there are probably some high values that are pulling that mean higher relative to the median, and so we have a positive skew. And in fact, that comes out to be true when we use Excel's skew calculation. So similarly here, we would assume this is positive, positive. These might all be positive. So here's one where the mean is less than the median. Okay, so what is that telling us? So if we think about the number of rooms, the middle of that data is somewhere around 7.5 or 8. But there must be, it seems to indicate that there's some pretty small homes as well, right? And if we scroll back up, we see a couple of those. So there's a 4, 5, a bunch of 6s. So, and these aren't very far apart, so it may not be a large skew. Okay, and so let's see how that shapes up. It did not. So they all came out. Well, it didn't work perfectly this time. And in reality, these are all fairly close to 0 skews, as opposed to say 3.5. So as we'll learn later on in the class, a skew of 3 is a pretty heavy skew. Or 2 or something like that, whereas 0.1 is pretty close to 0. So in reality, most of these have pretty symmetrical distributions. I did think it would come out a little bit better than only getting about 5 out of the 8 right. Okay, and then we'll come back to this variance and standard deviation in a little bit after we slog through the pain of doing it by hand. Okay, so we are going to go ahead and calculate this by hand or by hand with Excel's help, and this is going to look very similar to what we've done in class. Let me just kind of slide this out of the way, and we're going to again be looking at selling price, so we want to know how spread out this data is. We've already calculated the mean, right? Let me go back and look. The mean is 342,673. So I'm going to copy that and just paste it up here so we can remember. Whoop. So I tried to copy just the formula, and it didn't like that. Okay, so I'm gonna go recopy it. I'm going to Control-C to copy, but when I go up to paste, if I just paste it, it's pasting the formula, which is taking an average of stuff above it. That's why it yelled at me. So I'm going to right-click and I'm going to paste just the values. Okay, and that's going to copy just that number. Just so I don't have to keep scrolling down to see what that was. Now, when we start calculating standard deviation, right, what we're actually after is the deviations from the mean. And so this is all going to be related to the mean. Now, let's have Excel help us. You know, on the whiteboard, we had to write each of these out. Here, what we really want is we want a formula that takes the price. So this home listed as home number 1. We want the price minus the mean. So I'm going to come down here and just select it from down below. And now we know that that value was about 57,000 more than the mean. Okay, so I could continue to do that down here and hit equals B3 minus wherever the mean was. Or I can, again, work smart and know that I can drag in Excel. But when I drag in Excel, I need to be careful because right now I have B2 minus B45. If I drag this down, sorry, B2 minus B44. When I drag that down, I now have B3 minus B45. But B45 is not the mean. B45 is the median. And so when I drag in Excel, sometimes I need to lock those values in. And the way we do that, again, is with the $sign. So I'm going to use a $sign in front of the 44, which tells Excel, lock the 44. Okay, so now when I drag it down, the B2 is free to update. Right? Excel can see that I would like it now to be B3, which is the price of home number 2. And then, but B44 is still the mean. Okay, so I can quickly now drag this all the way down to home 40. And if you see on my screen, I have a bunch of $signs or pound signs. Hashtags, I guess. And that's an indication from Excel that they couldn't fit the whole expression in the area. So to counteract that, I can just double click up here or click and drag and make this cell wider, this column wider. Okay, so if you ever see those hashtags, it's because Excel can't fit what it needs to say in there. So you can just rescale. Okay, and so now we have the values or the deviations from the mean. Okay, so next step again, because let's use the sum equals sum. I'm just going to add all these up, and again, if you've been paying attention, you know what this is going to equal is 0, right? So the sum of the deviations is always equal to 0. That's not very helpful as a way to describe the variable. But if we square those, that'll take care of that issue. So again, let's use Excel to help us. We could rework this whole formula, and as you become more familiar, oftentimes you can fit these all into one, right? I could do B2 minus B44 squared, right? I could just build it all into one. I won't have to do column Q, but we have column Q, so let's just equals Q2 and then squared. So that's just the little caret and then to the 2. And we have a very large number. Okay, and that is 57,000 squared is, what are we in? Are we in billions? We're in billions. Okay, and now I don't want to lock that in because I do in fact want it to update as I pull down. And let's pull all the way down. And the numbers have gotten quite large again. And we can go ahead and sum, and I'm going to grab and drag over because Excel will update. And we have 270 billion as our total sum of deviations squared, right? And remember, what we're after here is standard deviation, but also variance, right? We're going to calculate one as we go. So, or both as we go. So the sample variance here, we have done now the numerator. We've summed up all of those squared deviations, right? So our column R here is x minus x bar squared, and then we've gone ahead and summed them down at the bottom. And that's the 270 billion. So the only step left for our sample variance is to divide by our number of observations with the little adjustment because we're dealing with samples. Remember, so with if it was population variance, we would just divide by n, but here we want n minus 1. And so our variance, let's see, how do we want? Let's just write it as variance. Whoops. Variance is we just want equals 270 billion something divided by, and this time I'm just going to type in 39 because I know I have 40 observations. Okay, and so we have a variance of 6,928,000,000 and so on. I'm in the way of it. We have a variance of 6 million. Okay, and you'll notice over here that we do in fact have a matching. I hope that shows up. Okay, yeah, that should help. 6.9 billion and 6.9 billion. Okay, so that's just to highlight that you don't have to go through this whole rigmarole every time you want to know the variance of a variable. And then standard deviation, right? What is standard deviation? It's simply the square root of the variance. Let me get out of the way. So that is just, so you can use SQRT to do square root. And we'll click up above, just take the square root of that number, and we'll see a lot of decimal points. Let me format that cell and get rid of those. I don't really care about any of the decimals right now. I just want to see that it is 83,000. Okay, and that matches 83,237. Now, again, as we talked about on Monday or Wednesday, the standard deviation is in those units, right? So when we're talking about home sale prices in the ranging from 210,000 to 520,000, standard deviation is in that kind of area, right? So we're in 83,000. The variance has ballooned, and we are at 6.9 billion, and again, that's actually in dollars squared, because variance is in that squared version. That's why it's getting so big. So as we talked about, that's why we kind of lean on standard deviation as a way to express the spread of a variable, especially when we're describing it. Okay, so that's crunching standard deviation by hand on Excel. And again, this is the sample standard deviation. We can come over here and just have Excel do it for us. Okay, and that's simply var.s, and standard deviation is stdev.s. Now, when you try to do variance or standard deviation, there are going to be some options. And we used var.s because, and this might be hard to see on the Zoom call, but it does reference that it is a sample, based on a sample. Whereas the var.p is the entire population. So again, those calculations are slightly different if you're going to use a population or a sample. And so Excel has both of those available to us. So we, again, if we want to look at that for the list price, just grab that data. We don't have to have calculated the mean, right? Excel will do that for us, or do it in its calculation. But again, we can just drag over as well. Let Excel update. Now, we have a whole lot of decimal stuff going on here. I'm just going to, just for the sake of our eyes, just quickly kind of generalize and put them all as two decimals there. But now we can talk about all of these variables. So if you're discussing with somebody about how many bedrooms there are in the typical home that's sold, you now have a mean of 3.27 and a median of 3. And you can talk about the standard deviation of 0.72, and that can start to give you a sense as to how likely it is that there's a home with 5 bedrooms or 1 bedroom. Okay. Other things, again, jumping back kind of into chapter 2, when we see data in front of us, we've done a lot of chapter 3 material here, but what about chapter 2 material? Well, we might want to display this in something like a histogram. So I've gone ahead and kind of built some bins. But remember, just to refresh our memory, we have some data on selling price here. We have 40 observations. So our rule of thumb is 2. So we want 2 to the k greater than n. So we want 2 to the k greater than 40. And 2 to the 6th. What's 2 to the 6th? 64. And 2 to the 5th is 32. So our rule of thumb would say 6 bins. And we need that to stretch from below 210 to above 520, right? We need to make sure everything has a home. Now, when we sit down to kind of build that, it's going to end up being a little more natural to end up using 7 bins, right? Because 7 is going to give us a nice clean 200 to 250, 250 to 300, and so on, all the way up above our maximum. And so, again, that's why it's kind of a rule of thumb, and we fudge it if it makes sense to kind of adjust, up or down a bin or two. And so I have listed here, I have myself in the way. So I have kind of our bin ranges, and then I've got it all ready to use the data analysis. So if you haven't gotten data analysis tool pack installed, you're going to want to do that because you'll need to use it this coming week. And so there's actually, let's see if I can. Just going to block out a bunch of the screen here, but if you're looking for it, if you go to File and Options, you'll see this come up. So if you click on File and go down to the bottom, there's Options. If you sorry, I'm out of order here. So down here, there's something called Add-ins. If you click Add-ins, and there is, so this will be posted as well, but there's a within the histogram video, this is also shown. So Add-ins, and then click Go. It's already with your Excel, it's just not active. Okay, so yours may show Analysis Toolpack unchecked, and you just simply check it and click OK. So you don't need to download anything else. And then you should be able to find data analysis up here in the data tab. And so that's going to be that shortcut, and we'll actually see it a couple times here. So we'll do the one that we're familiar with. We've seen this, the histogram. Okay, and that's not what I want. My input for my data, right? I'm curious about the selling price. I'm going to grab selling price. All right, I have my bins pre-made. Grab the bins. And then I'm going to output it. I'll just output it over here. Okay, and I'm clicking chart output so I get that histogram. Okay, and when I click OK, hopefully pops up here. And in fact, let me just scroll over. Okay, so we get our histogram. We also get our binned data here. So it's done much of the work for us. And so we can start displaying the data. Let me see. We're just going to shorten this up. As more of a histogram, and we probably want to just indicate these as 250K, 300K, and so on. Okay, and again, this is often kind of where data analysis starts, is summarizing the data in front of us and trying to grab a feel of what's in the data. Okay, so just another example of getting a histogram up and going. But the data analysis tool pack is more versatile than that. So we went through so we did all of the gross standard deviation by hand. We also had Excel do it, all of this descriptive statistics kind of one at a time. But let's go back to the data analysis, and it's kind of hard to see on the Zoom, it looks like, but there's one called descriptive statistics. Yes, Andrew asked if that's different for Mac OS. It likely is, because the file kind of system in Mac Excel is different, but the tool pack exists. So I'll see if I can find any resources for that. But a quick Google of data analysis tool pack for Mac Excel should bring you there. So there's a descriptive statistics option here, right? So we clicked histogram, but here's descriptive statistics. Now let's see what we can get from this. So I'm going to use the input range. I want to know about the selling price. Let's grab the selling price. Actually, I'm going to include this the label here, so it keeps track of that, and I'll click labels in first row. So I've grabbed from B1 to B41. And then I could have it put it out in a new worksheet, but actually I'm going to click. Guess I'll just. Oh, all right. I'm going to have it put it. We're going to put it here. I'll move those boxes. And I'm going to click Summary Statistics. Okay, and we'll see what it spits out for us. I'm going to need to move these text boxes. But here we have, Excel has gone ahead with a few clicks within the data analysis toolpack. I now have, for selling price, I have all of this information, and we can compare it here. We have 342,000. That's the mean. Some of the stuff is out of order. Standard error we haven't gotten to yet, but we do have standard deviation, sample variance, right? Those are going to match what we've done here. We have the skew. We have the max, the min, the sum, which isn't very, well, if we had a population, it might be helpful to know that the total sales were. Here's the median. Okay, so we have all this. We even have the count. So, you know, oftentimes, you know, I said we start with this type of analysis, but a lot of times we just jump right in and have Excel do it for us by using the data analysis toolpack. So that toolpack will return to a number of times this semester because it shortcuts a lot of what we would like to do. I'll probably, so just to foreshadow, you will have a, I may have mentioned this the other day, but you'll have a problem set for next week that'll kind of have you touch on a few of these things from chapters 2, 3, and 4 now that we're getting in, or we're kind of ending. Next week is kind of the end of our summarizing or descriptive statistics kind of trio of chapters. Okay, so handy way to summarize the data. You actually, just to show, you can do more than one variable at a time. So you don't have to just grab selling price. We could have it do it for as many variables as we want. Let me pick a new, I'll just do it down here below, and summary statistics. And it's going to spit out all of that information for all of the variables that I selected. Okay, and so you can actually, you know, we could have done that for all 8 variables that we have. So again, a quick way to do that, and it always spits it out with a lot of random decimals, so it does take a little cleaning, right? You don't need 12 decimals for kurtosis, which again is something we haven't covered. Okay. So what I want to turn to is grouped data, because we haven't covered it too much, and I know a number of you have already emailed me questions about the Connect assignments, and I think questions 10 and 11 maybe revolve around that. So what we've done, one of the things we did with this data is that we eventually looked at it in a histogram, right? And that included binning this data, which, anyway, but what if we got the data already binned? Okay, so if instead of we had a list of every here we have 40 values and we have a list of each price for them. If instead we got the data and it was already binned, so again, this may be survey data where you have to fill out, I sold my house at between these values, or some type of aggregated data, maybe on the city site or the state site had it just in binned form. How do we manage that data? And oftentimes there can be helpful information to be gleaned from that, but it's not as clean, or it's not as fully developed as that all the observations are for us. But we can take a mean of that grouped data and also get to the standard deviation of that grouped data. So just to point out that this is going to be kind of an estimate of the true value there, because we don't know all of the specific values. So we're pretending now that we don't have all of these 40 exact observations. Instead, we have the frequencies at which they fall into these clumps. Okay. I will point out, I think something's going on when I use the data analysis tool pack, and I include the labels. So my bins are off a little bit, and I don't exactly know. Let me just rerun this. Yeah, I'm not exactly sure what's up, but we've got a little mismatch of numbers here. But these are the right values for the bins. And so how do we go about this process? Well, what we're essentially going to do is we're going to take each of these values. So there's 3 values that fall between 200 and 250,000. We're going to treat each of those values as though they're right at the midpoint, right? Because that, without any other information, that's kind of our best guess as to where that value is. And you don't know where it is in the range, so let's just say it's right in the middle. And so that, what is that midpoint? Well, between 200 and 250 is 225. Okay, that's the mean of that bin. And similarly, between 250 and 300 is 275. I don't know if, yeah. So Excel is pretty good at picking up patterns. So once I had 225 and 275, I was able to grab both of those and drag down, and it could see that I was simply adding 50. Okay, so now we have a midpoint, right? And so that's the important kind of thing we have to calculate when we want to do means or standard deviations, is to grab or figure out what that midpoint is. And now we treat each of them as though they are right on that midpoint. And so the mean really becomes a weighted mean of those values. And so I have the formulas over here. Quite small. We can zoom in, especially here. So the mean of the group data is the sum of f times m, where m is that midpoint and f is the frequency. And so we need to calculate f times m. So in Excel, we can just do 3 times, or C5 times D5. Right? And so because there's 3 of those, they total to 675. Let's go ahead and drag that down. And that's going to do that for each of those pairs. Uh, we could, in some sense, we could reorganize this and just say, get rid of this whole frequency business and just write them all out. Right? And count them each as individual observations, where there's 3 225s, and then I write out 13 275s, and then 8 325s. But that's very cumbersome. But we could do that and then do our same method that we did before. But we don't need to do that because we can use kind of the tools of that weighted mean to do this. So to find the mean, we do sum of this column, right? Because that has included, or that has all of the weights in it, or the frequencies. And so this is the total out of these 40 observations. Let's just double check that there are 40. Okay, so 40 observations. There are a total of 137,000. So we're in thousands. So that's, that's 13,000. So we're in 13 million. And then lastly, we need to divide by n. Okay, and we'll take this number divided by 40, or our count. Okay, and we return to 343. So our average, or our mean of the grouped data suggests that the mean is 343,000. Right, for just ease of typing, I've kept this in the in the thousands unit, but we can scale that back up. So let's just multiply. And so our guess, if we just had the data in this grouped data from the frequency bins, we'd make an educated guess that average home sales in the month were 343,000. Okay, and let's jump back. And in fact, that was a pretty good guess because the mean was actually 342. Okay, we're not always going to have that to reference, but in this case we do. And so that grouped data was a pretty good estimate of the actual values. Okay, we can do the same thing, or we can keep going with the standard deviation. Now we need, so we're treating them each as the midpoint as the value there. And so to calculate standard deviation, we're going to rely on the standard deviation of the group data. So we can have Excel do this for us. So what's M? Well, for this group, it's 225. Let's subtract off the mean. Okay, that's at 343. So for those three values, the midpoint, or the value for those is 118,000 less than the mean. I'm going to go ahead and drag that down, but I do need to lock in the E13. And so now I can do that for each of the values. Okay, so we see eventually they're greater than, and we should yeah. So one thing to note is that these the sum of these is not equal to 0, right? All the other times we've said that the sum of the deviations is equal to 0. But remember, we're dealing with frequencies, so we're not actually doing all 40 values here. Not until we include the frequencies would that be true. Okay, so that's only true if you're counting up. Remember, because there are 3 of them at this, at negative 118, but there's 13 at negative 68. So if we haven't accounted for the numbers in there, then, or the frequencies, then this sum is not going to be 0. Okay, so continuing, we want to build that numerator here. So m minus x bar squared is just going to be this column squared, right? Just use that caret squared, drag that down, and we now have the start of the numerator. But again, we have to take into account the number that are of this value, right? So when we count them all up, when we sum them up, we want to make sure that we're counting all 3 of this first bin and all 13 of the next. So we need this final f times m bar. Okay, and that's just simply going to be the frequency times what we just did. Okay, and a lot of times, again, you can kind of, once you're familiar with what you're trying to do, you can smush all of these columns together into one kind of formula. But now we have the most of the numerator. All that's left is to sum it up. So let's go ahead and use the sum command and sum up this column, which includes the frequencies and the distance, or the deviation squared. Okay, and now we have the numerator. And if we wanted the variance, so s squared for the variance, maybe we'll just write it as variance. The variance is simply now the numerator divided by 39, right? So n minus 1, again, because we're in the sample world. So we end up with a variance of 6,000 or 6.8 thousand. Okay, and then lastly, standard deviation is going to be the square root of the variance. Okay, and we have 82.96. Now, as we talked about on Wednesday or Monday, the variance and standard deviation, again, are in the units that we're talking, or standard deviation is in the units, and the variance scales up from there. So what we did on the previous sheet was in thousands of dollars, or it was in dollars. This is in thousands of dollars. So we can scale that back up and say, so 82.9 times 1,000 is going to be 82,000. Right, so standard deviation in dollars is 82,000, 82.9 thousand. Let's go back and check how well this estimate. Again, this is an estimate based on that midpoint. How did we do? Standard deviation for this data was actually 83,000. But again, really pretty close for just having the midpoint of all of these values, or the binned value. Okay, so if we have data in grouped form, or in that kind of survey kind of style where you just pick within a range, it ends up that we can get a pretty good feel for what the real data would show. Now, I can't just multiply by 1,000, remembering that variance is actually in the squared form. So what I actually have to do is times 1,000 times 1,000, right? And so that's going to be a huge number. I can't even really tell what that number is. Let's format these cells just to... Should have put commas in there. There we go. So we are back to 6.9 or 6.88 billion. Again, let's jump back. What did we have before? 6.9 billion. Okay, so again, the variance did a pretty good job here with the group data. So it's a little more of a process, right? There's a few more steps when dealing with the group data because we have to keep track of those frequencies. But we can get there. And get a pretty good feel for what's going on with the data. Again, without having all those 40 observations, we just had people say, I sold my house between 300 and 350,000, or 450 and 500,000. That's all they clicked on their little SurveyMonkey results. And in fact, we got a pretty good feel for what the true values were in that the actual data. So the Connect assignment does have you kind of walk through or sketch these out. Again, I think it's question 10 and 11. So hopefully this gives you something to reference. You can go back and watch this and see how I've done it here. Yeah, and that's really kind of process that we do for that. So that was a lot of just throwing stuff at you, but hopefully gave you some familiarity with what we can do in Excel and have Excel make our lives easier. Yeah, and so again, this will be up, and I'll probably post a finalized version of this too, or something close to this, so you can kind of see some of the formulas I've done along the way. Other than that, we'll kind of stop here, and I'll hang around for a little bit if people have questions. Otherwise, remember that Connect assignments due Sunday, and it is longer. It's going to take you more time than the previous ones. So if you haven't started it, don't wait too long. And then, yeah, we'll jump into Chapter 4 next week. There'll be a couple sections or a couple short things that I might have you skip. So look for that. And then, yeah, there'll be a Connect assignment probably due next Friday, because I'll have a problem set due Sunday. And then that'll get us on a kind of a better schedule as we approach an exam, which will come after Chapter 5. So to kind of scare you a little bit into starting to refresh some stuff. So that's where we're headed. But yeah, other than that, we'll see you either Monday or Wednesday, digitally or analog. Is that a right term for in person? I don't know. Probably not. Yeah. Otherwise, I also have office hours this afternoon from, good question, 1:30 to 2:30. I'm pretty sure. And yeah, so I'll be here on Zoom, same room, if you want to jump in and ask any questions there as well. But yeah, otherwise we'll talk to you soon.